Hey coding buds. So basically in today's GFG PPT we have a problem queue reversal, and it is the easier of problem, and the statement is given a queue containing integers element. Your task is to reverse the queue. Here we have an example like 5, 10, 15, 20, 25. Okay, so after reversal we actually getting 25, 20, 15, 10 and 5. So here we have to just simply perform our reversal operations inside the queue. And here similarly we have the second example here, and the constant is given as q dot size must be like greater than equal to 1 and less than equal to 10 to the power 3, and q of I should be like greater than equal to 0 and less than equal to 10 to the power 5. And we need to solve this problem with an expected time complexity of order of n and expected also space of order of n. Here this question is like asked in Amazon, and this is like completely based on stack queues data structures. Okay, so here we have to just simply perform the operations like reversal inside the queue, and this thing which we can easily able to get it by using two ways. First of all by using stack, and secondly by we can simply do it by using recursion. Okay, so I'm going to explain you about both the approach here. So let's understand this. Here in the first type we can say that here we are actually solving by using recursion, where we actually were doing where we have just simply created a variable storing the front value of the queue, and then after that we have to just simply pop out, and then again we have to do recursive operations and check for the remaining elements inside the array. Like here in the first if I'm talking about this particular example one here, so here we have 5, 10, 15, 20 and 25. So first of all we have to store this our front value, and then after that here we have to do then after that here we have to just store it and then pop out, and then after that again here we have to just check recursively for the remaining element which is like 10, 15, 20 and 25. Then after that what we will do, we again store its front value. So now this time here we have like front value as 10, so we just simply store it, and then after that we again simply performing our recursive task until our array will not become 0. So once we have like done these things, and at this point it is like we can say that our functions will end. So once our functions will end, again we are actually going to trying to push our elements, that means front element, inside the queue here. So while pushing it, so here we're actually getting 25 first, then we can set it 20, then 15, then 10, then 5. So we are actually getting here we can say that a recursive element inside the queue. Now second way is like by using stack. Now we know about stack. Stack is also we consider a linear data structure which for the principle of first and last out, and here we can do insertion and deletion at only one end called top. Right, so here what we will do here we just simply create the stack, and we just simply in the first step we are just while our queue is not going to be empty, we just simply take each and every type of element inside the queue and push it into the stack. And we know very well our stacks just simply make our element automatically recursive. Okay, so here what we will do, here we just simply put it inside the stack, and then if I again like getting it from the stack, we actually getting the we can say that recursive element inside the queue. So let's try to solve this problem here. So here I'm going to try to solve this problem by using recursion. Okay, so here what we will do, first of all we have to like write our base case. So here I can see that here in the base case what I can write here, base case, if we can say that if queue is empty, okay, then we have to just simply return. That means if no any other element inside the queue, then we don't have to perform any other operations. But if there is any element, inside the queue, then what we have to do, first of all we have to first of all create a variable. Let's say here I am saying that int front, and storing our front value inside the front variable. So here we have to just simply take q dot front, and front is actually a method which basically turns our first value of the queue. And then after that, once we have like done these things, that means once we store our front value, that means I am showing 5, then we have to remove it and locate at the remaining arrays. So here what we will do, here we will just simply do q dot pop is also a method for removing this element, and then after that we have to just simply recursive call, that means reverse q is our main function. Again we have to pass the remaining q. So here we have again passed the q, and this will perform till our recursive q will not be going to be end. That means about the functions. Once the function will complete end, then we have to like take all these elements back. Okay, so we just simply do what here to just simply we can say that q dot push. We can say that we have to store our front value. Okay, so yeah, once we have done these things, we are actually getting our remaining output. Let's try to compile and run. So yeah, here compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching. Let me explain the second code also here. Okay, let's say if I'm talking about by using stack here. So here we can say that if q is not empty, while q is not empty, let's say here in the second approach. Okay, second approach, I'm going to talk about this approach also here. So let's say first of all what we'll do here, we have to traverse first of all inside the queue. That means while queue is not empty, until our queue is not empty, what we have to do, we have to store our element inside the stack. That means here we can say that s, but before that we have to create a stack also. So here we can say that a stack of integer type, and let's say I'm defining as s. Okay, then s dot push, and inside that we have to push all elements of that means q dot front element. Okay, once we have like done these things, then we have to just simply do q dot pop. Okay, that means we have to remove our front value. Okay, now once we have like done these things, then again we have to check it from the stack while the stack is not empty. Okay, while s is not empty, then what we have to do, again we need to get back all the elements inside the queue. So here we can see that q dot push, and then here you can see that s dot top. That means here we have to take the front element or top element, and we have to insert it inside the queue like by using this way. First of all we have to take this value, then this value, then this value, like that way. Okay, so again here to just simply say that s dot once we have done these things, then here we again get to set it s dot pop. Okay, once we have done these things, we have to just simply return it here. Okay, let's try to compile and run. So here this approach is also compilation is completed. Okay, so yeah, that's all for today. Thanks for watching.